Welcome back, learners. So now to jump into our first concept, whereby we're going to be looking at what this force is, what actually is this force that you're talking about, and how do we measure this force, and what are the effects of this force. So to begin, we need to understand what this force is. So this term that you're talking about, the force, is often associated with the size of a human's muscles. It is sometimes confused with the energy or the performance of a person, an engine, or even a machine. So we sometimes confuse this force with the energy or the performance of a person, or the energy or the performance of a machine, or even the engine. However, in reality, the forces are invincible. We can only see the effect of their effect. So we can't see a force, but we can only see their effect. For instance, if I push you, we're not going to be able to see the force that pushes you, but you're going to be seeing the effect of what happens after I have pushed you. Now, a force, as we've said, it is a push or pull, or sometimes you can even say a twist that is exerted on an object. So whenever you are pushing an object or pulling an object, you are actually applying a force onto that object. Now, you're going to be seeing if whether the object has had a force being applied to, if that object moves, or sometimes nothing happens to the object, because those forces that are there, they can sometimes be balanced. So when two objects interact, the one object can exert a force on another. So the forces that you're talking about here, as we've said, they are always acting in pairs. So when two objects are interacting, one object can exert a force onto another. We can take, for instance, two blocks. Now when these two blocks collide, we are then saying that one of the blocks is going to exert a force onto the other block. So we may not know which block exerts a force onto which one. All we know is that these two blocks are going to exert a certain amount of force onto each other. So block A will exert a force on block B, and also block B will exert the very same force onto block A. So there are different kinds of forces, and whereby now the type of the force or the name of the force depends on the origin of the force. That is now how the force came into being. So if I push a wall, if I apply a force onto the wall, or apply a force onto this block, the name of that force that was applied will be an applied force. Now, if I push a block onto a surface or through a surface that is rough, the force that is exerted between the surface and the block is going to be friction. So there's friction between the block and the surface. So the name of that force, it depends on the origin of the force, or how that force came to being, as we have said. Now, this force that you're talking about here, how do we then measure it? We need to know that the unit in which a force is measured, it is Newton, or we're using the capital letter N. So for instance, if we're saying that the force applied is 10, it cannot just be 10, it needs to be 10 newtons. So the N is now the unit of measure for a force. Now this Newton is named after a famous scientist which is known as Sir Isaac Newton. A force has a size, also a force has a direction. So now when looking at this picture alongside, a boy throws the ball forward in a forward direction. The amount of force applied onto the ball becomes the size of the force, and the direction in which the ball is taking, that's the forward. Now that becomes your direction of the force. Now, what are these effects of these forces that you're talking about? Sometimes the force that is exerted on an object is too small to have a noticeable effect. In other cases, whenever you're applying a force, you can actually see that a force has been applied here. And remember, we're saying that sometimes you cannot notice that there was a force applied, and then sometimes you can actually notice that there was a force applied. So how do we then tell if whether a force has been applied? We need to know that a force can change the shape of an object. So if we apply a force into an object and the shape of that object changes, then you should know that a force was applied. And also, a force can change the movement of an object. Now, how does the force change the movement of an object? It does three things. Number one, it puts a stationary object into motion. So if an object was stationary and I apply a force onto it, that object will start to move. Now, if it moves from being stationary to now starting to move, then a force was applied. Also, the movement of this object, it can be increased or decreased. The speed of the object can be increased or decreased, or sometimes the object, if it's in motion already, it can be put to a stop. So we can either increase the speed of the object or decrease the speed of an object by applying a force. Or sometimes, if the object is in motion already, I can apply a force onto it and it comes to a complete stop. So now, when looking at the direction, the force can also change the direction at which the object is moving. So now, if we have a wall and then a tennis ball is thrown towards the wall, the wall is going to apply a force onto the tennis ball. So the tennis ball was going to the right, and then the wall is going to apply a force onto the tennis ball, and the tennis ball will now bounce backwards and go to the left. So the force applied by the wall onto the tennis ball has changed the direction of the force, the direction of the object. So three things need to happen. So now, number one, we're saying that a force can put a stationary object into motion, or sometimes it can increase or decrease the speed of an object if it's in motion, or even make it to come to a complete stop. And then the third thing is it can change the direction of an object if it was already in motion. If it was going to the right and I apply a force onto it, and that object will go to the left or go to any other direction in which the force is directed. Now, continuing with the effects of these forces. Multiple forces can simultaneously be exerted on a single object. Now, that means two or more forces can be exerted on the very same object at the very same time. Now, when we are exerting forces simultaneously onto one object, they are going to have a combined effect on the object. So now, when we're adding up all those forces that we are applying onto that one particular object, they are going to have a combined effect. Now, if forces are exerted on an object but there is no visible effect, we are then saying that the forces are balancing each other. So if those forces are balancing each other, we are then saying that those forces are at equilibrium. So now remember, we can exert multiple forces onto a very same object. Now, if there's no noticeable change in that object after those forces have been applied, say for instance, we have a block and there's a force going to the right and also another force going to the left. Now, assuming that we are applying a force of 10 newtons to the right and a force of 10 newtons to the left. Now, this object, if it doesn't move, that then means that the two forces that are applied onto this object, they are going to be balanced. They are going to balance each other. Now, also, because this object will not move, then those two forces are said to be at equilibrium. Now, with that said, and before going on to the next concept, we're just going to quickly go for a short break, and I will see you just after this.